len, and so on, various inbuilt functions in Python. Uh, these inbuilt functions are sort of the kind of functions that we commonly end up using. Like there are a lot of these functions that we end up using commonly. So let's start with a few of them. If I have a string, let's call s1 equals, let's say hello world, and yeah, just 1 minute. There we go. Let's say we have hello world. Now, if you want to know how many characters are there within this entire string, you can just use len of s1. Len is an inbuilt function that will go through an iterable. Again, this is a keyword of Python I'll keep repeating a lot. Iterable is where you have an element which has a series of elements within it. In this case, each element is a character, and this is the series of elements within it, which has 11 characters in total. So if you just run this particular file, you'll get the output 11 because the number of elements or the number of characters within the string are 11. And len can be used for any kind of iterable. We have a few iterables that we will look at in time. We have a few iterables that we'll look at in future. But this is one thing that you just need to know for reference. Moving ahead. Um, there are a few more inbuilt functions which are like max, min, and there are so many of them, but I will not be able to go through them right away because we have not started to look at uh, iterables with numbers, that is data structures such as list. So I will um, keep these temporarily on hold for now. We'll probably take a look at this later once we go through data structures in Python particularly. But yeah, and now that we know length of it, let's go ahead and take a look at operators. There's one more inbuilt function. Let's take a look at that as well. So I'll take x is minus 10. And if you want to print absolute value of x, it just makes sure that whether it's negative or positive, you're going to get only the positive value out of it. So it's something where it returns the absolute, that is non-negative value of a number. Whether it's an integer or float, that doesn't make a difference. It's just going to return a non-negative number of it. Anyway, moving ahead from here, let's move on to operators, basic operators. We know a lot of operators already that are basic when we start working on programming languages, that is addition, subtraction, multiplication, and division. But Python offers two different kinds of divisions, basically. If I have, let's say, a equals 5, b equals 2, and I'll just input IC, and I'm just going to use IC of a divided by b, and again IC of a divided by b. The idea here is that when you perform division with a single division symbol, it will always return float value if applicable. Float division, this is always going to return int value, that is a round off to the lower bound. So if you run this, you can get to see a divided by b with a single division symbol, you're going to get 2.5, whereas this, what we call as floor division, will return exactly 2. So this is just a basic thing that we have when we talk about operators. Similar to this, another operator we have is star and double star. This is not exactly the same as division and floor division. The whole idea of star and double star is if you print a into b, and if you print a double star b, this is basically the same as a to the power of b. This is a multiplied by b. That's pretty much it. So if you run the same case scenario, a is 5, b is 2. 5 times 2 is 10. However, 5 to the power of 2 is 25. You just get the basic idea of this. Another way you can use to the power of is also to perform square root and other operations, for example. I'm just going to take one very small example for this. Square root, let's just print IC of 8 to the power of, or 25 to the power of 0.5. 0.5 is basically 1 by 2, and anything to the power of 1 by 2 is essentially the square root of it. So when you run this, you're going to get 5. We use power to perform operations like this. Just for our reference, this is some minor difference that we need to know uh, in Python in terms of operators that are slightly different from operators of other programming languages. Apart from this, there are other operators, particularly like bitwise operators, but we're not really going to go into them. It's not going to be a superbly useful operation. However, I'll just give you a minor introduction of bitwise operation, and I'll just give you a small example of where bitwise operation becomes important if you're performing certain mathematical operations to improve the efficiency of your code. If you remember, one of the common themes that you've noticed since the last hour or so that I will be speaking about is efficiency, ensuring that your code is as efficient as possible. That's the whole purpose of your code. In this case, there are certain bitwise operators that we can use to make our code superbly efficient. So again, I will not go through entire set of bitwise operators because it's not something that we will use on a daily basis when we start coding. However, if you are performing some mathematical operations and you want your code to run even slightly faster than any other code, this is going to be something quite useful. That's something we need to just know and be aware of. So I'll just take this for an example. Um, just before we go on to bitwise operators, I just have one query to all the participants. Let me just close this off. Yeah, just have one query to all the participants. How familiar are you with working on binary bits, particularly? Because I know it doesn't revolve around our everyday work, but just wanted to know how familiar are you to work on binary digits and or binary numbers and performing addition, subtraction, or various other operations on binary numbers. All right. Right. So yeah, I've got a couple of responses. Nice. So that's totally fine. We're not gonna go quite in depth when it comes down to this. I'm just taking one very small example so we can um, just take a look at how we can use it in some real case, for example. Now, when we talk about bitwise operators, there are quite a number of bitwise operators like and and or this XOR and not left shift and right shift. Again, this is not something that we'll use on an everyday basis, so I'm not gonna really focus on them. But if you would like me to focus on each of these operators with maybe an example to see how they work and where we actually use them, I can do that. So please let me know if you would like me to walk through them in greater detail. Otherwise, I'll just take one or two examples and just show you how we can utilize them to improve, let's say, code efficiency in some way. All right. So yeah, given some of us are familiar, some of us are not familiar, I think it's fair to say that we can go to a moderate amount of depth in it and take a look at it with some real world cases as to where we implement them. Right, so we'll do that. But before we do this, I just want to point out one little thing. I'm going to use a for loop here to understand, or for us to understand the timing of it, as in how much time it takes. But I will be using that only to calculate time. However, you can walk through for loop later on because I haven't gone through the constructs like if, else, for, and everything. I haven't gone through them. So I will walk through for loop later on to understand in what ways can we use them and how can we make effective utilization of them in real cases. But yeah, prior to that, I'm just going to import an inbuilt module called time. This is a module that we're just going to use to calculate the time taken to perform some operation. That's one thing we're just going to use. So time is an inbuilt module where if you just use the time function within it, it's going to give you the current time in seconds. Our idea is if you're going to perform some bitwise operations, we're going to calculate the time before performing it. And we're going to store that time as start time. After performing the bitwise operation, we're going to calculate the time again and store it as end time. Once we have performed this, we just calculate end time minus start time. This will give us information as to how much time has it taken to perform this particular operation. It might not sound too much. It might sound like, hey, this is going to take just a few milliseconds at worst. It's not going to take quite a long time. That is completely understandable. I totally get the point in that sense. However, when we start working on Python, when we start working at a larger level, every millisecond counts. Think about this. I'll just give you a small example of one of the recent applications I've developed for a client to understand this better. We've recently worked on a voice automated system where if you make a telephone call, it would recognize your voice and generate a response. So if I make a phone call and say, where is my order? Or if I just specify my order ID is 234, my user ID is 456, I need to know where is my order ID or what is the status of my order ID. Then the application would listen to your entire voice, go over, search the database to figure out um, does this user exist? Does this order exist? And then respond by stating where the user's order exactly is. This particular application had a lot of things. You had to connect to the database, you had to understand human voice, you had to convert it to text, you had to do a lot of things, right? At this point, we needed to make sure that the application would respond as quickly as possible back to the user. And time always helps perform that. It's a basic functionality, but it always helps perform that. The whole purpose is we figure out the start time and end time for the speech recognition. After calculating speech recognition start and end time, then do the same for the database calls. Figure out which one is taking more time. Whichever one is making more time, optimize it afterwards to make sure you get a faster response as a user. So this is just one small example that I wanted to provide to you as to where and how we use it. And that's exactly what we're going to do. All right. So with this idea of time, let's move ahead. But before we go ahead with that, so since some of us are new to binary, let's just go back to this. Our computer cannot understand human language or anything. So our computer basically stores everything in electronic signals. These signals are either switched on or off. That's basically why we call them ones and zeros. That's the whole idea. Everything that we ever do in computing is purely based on binary data. Whatever I'm typing here, whatever you're listening to, all of these are basically in one form or the other, some sort of binary data that are being transmitted, but they're decoded in different ways. That's the whole idea. But when you're storing everything, it's either ones or zeros. That's how we get to figure out. The idea of binary numbers is pretty simple. you start with numbering in this way. Initially, 0 is 0, 1 is 1, then you go ahead further on. Now, I'm just going to talk about 4 bits, or let's only go to 3 bits for now in interest of time, because our main purpose is understanding Python mainly and not to purely go into binary numbers. So given some of us are new to it, I'm gonna take it up to 3 bits for time being. However, if you would like me to go through further detail, we can definitely do that. So feel free to let me know. So on a 3-bit level, let's start with this. This is going to be 0. Let's start with the next one. This is going to be basically 1. We start increasing at this level. So the whole idea is that each digit can be converted from binary to a decimal base number just by multiplying them. So this is going to be the last number is going to be multiplied by 2 power 0. Then the next one will be multiplied by 2 power 1. Then the next one will be multiplied by 2 square, and so on and so on and so on. So 1 times anything to the power of 0 is just 1. 0 times anything is 0. 0 times anything is 0. And we basically get 1. This is how we get to convert binary to decimal in short. And yeah, that's pretty much it. 0, 1, 0 is 2, and so on. 0, 1, 1 is 3, and so on. I'm not going to go for further detail. Let's just take a small example for us to understand. Again, for our reference in this case, this is what we have. 0 times 2 power 2 plus 1 times 2 power 1 plus 1 times 2 power 0. Um, Anything multiplied by anything to the power of 0, you get the same value, which is going to be 1. 1 times 2 power 1 is again 1 times 2, which is 2. Then 0 times anything is 0. Hence we get 3. So this is kind of like how it essentially works, right? Now, onto this case, there are a lot of simple operations that you can perform. Let's start with one of them. Again, I will not go through all of these. I'll go through the major ones that I want to show you the difference in terms of um, how you can utilize it in real life and how you can utilize it for your own purpose of making your code efficient. That's the main purpose of doing this as of now. So let's take a look at AND operation. The idea of AND operation is just to multiply. It's essentially to multiply. So if you have 2 and 3, let's take 2 is 0, 1, 0, and 3 is 0, 1, and 1. You basically multiply them in such a way that if both are true, your result is true. Again, these are purely based on electronic circuits and logic design, which is implemented over here. But I'm just going to stick to a basic explanation of it. As long as both signals are high, or both signals are on or true or one, whatever you want to call them, the result will be one. Otherwise, it's just going to be 0. Hence, you're going to get true itself. This is basically how AND works. However, AND can also be used for some other purposes. Think about this. You have your own application which needs some mathematical operations to be performed. There is modulus required in something. It could be in machine learning for all we know. We need to calculate this in some convolution neural networks, for example, or you might need to perform modulus for various image-based operations, or some data analysis could be anything. When Okay, again, to point out, I again understand that this might be a very small operation to literally identify, like, hey, it's way too small of an operation to identify how good this can be useful. But let's take a look at how good this can be, or how useful this can be in our case. Now, I'm just going to take some number, let's say, and n minus 1. This is a short form, or this is a shortcut formula, or you can say that, where you're just performing x mod n given the condition that n is a power of 2. So n can be 2, 4, let's say 8, 16, 32, or so on. So whenever such a scenario happens, if you want to perform modulus with a 2 power, Instead of performing x mod n, which performs all the mathematical calculations, you can just perform x binary or bitwise and n minus 1. This performs it in a much smaller and shorter way if you calculate this. Again, I'm not going to go for the calculation of it, but I'm just going to show you for reference. I'll take x equals, let's say, 1398, for instance, and n is 32. I'm just going to print x and n minus 1. Yeah, sorry for this. And I'm also going to print I see x mod n. Let's run this. You can take a look at this. Both the results are 22. Both are giving me the same exact responses. But how do I know this is faster? So to do that, I'm going to make a small change. I'm going to create a start time as time.time. Now, please remember, we have imported a module called time. This particular module called time is going to have certain functions that is going to give us what is the current time. So we have a function within the module time called time. This function gives us the current time in seconds, as we learned, and it's always since the epoch. So for those who don't know or who might not be aware of this, epoch is calculated by January 1, 1970. So you might have seen some old PC which um, might not have a good enough battery to store dates and remember dates, especially when it's offline, it's not connected to the internet. And in that case, since it might not have enough good enough battery to remember dates, which we basically call a CMOS battery, the default date it will be stuck back in every time you restart that PC will be Jan 1st, 1970. It's just the default date or default epoch every PC takes up. That's just um, one thing that we need to know. So since the default epoch, how many seconds have passed till now? That is what time function provides us. Once time function provides it, we're going to get the start time. And once we do that, we're going to repeat this operation 1,000 times or 100,000 times or something. So I'm just going to use a loop for it. And I will not, for those who are new to Python and who might not be able to understand this looping construct immediately, though you know looping, please don't worry. I will walk through looping later on. I'm performing this only for us to understand time. So let's start with this. For I in range of 1, I'm going to take a very large value. So it's going to repeat these many number of times. Again, I'm going to walk through this later on, so please don't worry about it now. And I'll just calculate end time, and I'm going to print here time taken with bitwise and is, let's call it as end time minus start time. That is the amount of seconds it took to perform this. Instead of IC, I'm just going to write it as result equals x and n minus 1. We're just calculating the result in our case. Now, with this understood, let's repeat the exact same thing. And this time, we're going to repeat it, this whole logic. Instead of x and n minus 1, I'm just going to make it x mod n. That's pretty much it. So let's run this and see how this might work. So if you take a look at this, you can observe with, okay, I'm sorry, one minor mistake. This is not bitwise, and this is with modulus. There we go. So you can see it's not a big difference in our example. Just so you know, this has taken 0.08 0 seconds, and this one has taken 0.087 seconds. It might not seem much. It definitely does not seem much. But when you're performing millions and billions of operations constantly because of some possible, let's say, machine learning operations or very large scale data manipulation operation, this makes a difference in that sense. So whenever I talk about efficiency, you might see me talking about efficiency, even though it comes down to, as we talked about earlier, in terms of milliseconds. But here you get to see the difference it really makes when we scale it up to, let's say, a lot of times. That's just one thing that we need to know to understand it. Again, it's not a big difference in this case, but I just wanted to show you of how certain things would make difference when you work around them with binary or bitwise operators. So a lot of things, whenever you're performing with 2 to the powers, that is, you're multiplying with 2 powers, you're dividing it with 2 powers, all of these you can literally utilize them. So just one thing for you to note. Again, we'll not move in greater detail with this, but that's just a basic thing that we just need to know. Anyway, moving ahead with this. Before we go on to the next kind of operators, that is and, or, not, in, not in, I'm just gonna separate them. And let's say is and is not. Before we go ahead with these, let's start to take a look at conditional operators, sorry, conditional constructs, and observe and understand that first. Once we know that, we can then go ahead and work on these. But yeah, this is just a basic part. But if there are any queries still here, please feel free to let me know. If there are no queries, we can move ahead right away. All right. All right. So I guess we can move ahead on this. So let's take a look ahead now. When we talk about conditional constructs, you might need to perform certain operations under some conditions, under some specific conditions precisely. Now, let's think of this. Let's say, okay, just please hold on for a few seconds. All right, all right, let's go ahead. Let's say we have certain simple logic to implement, like, for instance, mortgage based on credit score, or a loan based on credit score, for instance. All that we need to do, or we need to perform here, is, let's say, for instance, if the credit score is below 300, you have to tell the user or indicate to the user that no loan will be provided. Let's say if credit score is between 301 to 599, or let's say 600 rather, let's say loan will be provided with scrutiny. Again, I'm sorry for some minor typos. Yeah, just gonna copy this to avoid taking time to type this. Let's say 601 to 800. Loan will be provided with guarantees, or with collaterals, let's say. And finally, if loan or if credit score is above 800, let's say loan will be provided with just some basic information or something like that. This might not reflect the real world scenario, but I'm just taking this up so that we can take a very small example and understand conditional constructs in a very quick way. As in any programming language, again, I'm just going to walk through this in such a way that some of us are familiar with conditional constructs, some of us might be new to it. So again, requesting, this is something I keep stating constantly. I know again, so just requesting at any point of time, anyone who feels like you want me to go slower with some greater detail into it, or just go faster ahead, whatever it could be, please let me know. Right. Moving ahead. In terms of conditional constructs, if certain condition occurs, like for example, credit score greater than 300 or credit score is lesser than 300, then loan will not be provided. So you might need to write 5 or 6 lines or 10 lines of code. Previously, in other programming languages like C, C++, or Java, we used to have brackets here to identify the number of lines that you might need to write. This could be, let's say, 10 or 20 lines of code that you can write within the brackets. And any code written within the bracket is a code that will be executed only if the condition is true. However, Python is a programming language that does not allow brackets. There are no concepts of angular braces or sorry, curly braces like these to identify block of code that will be executed for some condition or function or so on. Instead, Python relies based on indentation. It purely relies based on indentation. In other words, if you write a condition, if credit score is less than 300, you don't you write all the lines that you have to write that should execute within the if condition, and all of them should be written after X number of spaces. And this X should be common throughout this if condition. So if you're using 2 spaces for the first line, it should be 2 spaces for all the other lines that should be executed upon this condition being true. That's the whole idea. And once this condition has ended, rest of the lines will be written as it is. So if this condition is true, you're going to execute these lines and then execute these lines. If this condition is false, you directly execute these lines, which are in the same level. This is how Python works. And this is a reason why um, a lot of people look at certain conditions and they write conditions in conditions in conditions and so on. And because of a lot of indentations, it makes your code horizontally larger, which is frowned upon when we look at in terms of um, pylint or linting. I have a simple solution for that, which I will just walk you through with an example later on. But let's get back to this for now. Now, once you write a condition, you need to use colon to indicate the beginning of indentation. After colon, you start indenting, let's say 4 spaces, for example. All these lines are going to have 4 spaces each. That's your whole idea. And this is basically how it works in terms of conditional operations. Let's just try to implement it very quickly. We're just going to take an input here from user. Let's call it as credit score equals. Let's take an input from user as enter your credit score, for instance. And once user enters their credit score, let's just check if credit score is less than 300. I'm just going to print you are not eligible for a loan. Now, before I move ahead and run this logic, can you just take a look at this simple logic and let me know if you feel it might work or it might not by any chance?
Won't it throw an error because it's a string credit
Absolutely
score?
right. Absolutely perfect. Because you cannot perform a comparison operator like lesser than, greater than, or any such with a string. So we have to wrap it with an int so that we get an int response, and we can do this. Also, just so we know, the comparison operators that we have are lesser than, greater than, lesser than equal to, greater than equal to, not equal to, and exactly equal to. These are the ones that we have. Moving ahead from here, let's go on to the next part. In our case, once we get to know the credit score, we're just specifying if credit score is less than 300, we're just printing you're not eligible for a loan. But you can write any number of lines you want here, let's say A, B, and C, whatever number of lines you want. And once you're done with this if condition, just go back ahead and continue your next line, whatever it could be, for instance. But yeah, in our case, we're just going to have one line and we're going to go to the next case. Now, I'm going to perform this with completely if conditions and we're going to change it to elif and else by the end. So we can improve our constructs one step at a time. So the second condition is if it's between 301 to 600. So if credit score is greater than equal to 301 and credit score less than equal to 600, then we're going to print loan provided based on scrutiny and collateral. The next condition is if credit score greater than equal to 601 and credit score less than equal to let's say 800, print again loan provided with collateral or something like that. Yeah, provided with collaterals. All right. Then the last one is if credit score is greater than equal to 800, we're just gonna print loan provided instantly or something like that. Now, here's the problem with this particular code. Once I run this, if I provide, let's say 500, it's gonna say loan provided based on your scrutiny and collateral, which is absolutely fair, which is absolutely right. However, this code is highly inefficient. It's a brute force way of working around this code, which is the least efficient way we can work around it. And I'm just going to walk through why about the same. Now, let's just think about this scenario. Let's assume that our credit score is 280. At this point, the moment we enter the credit score, we'll have a value of 280. We go to the first if condition. It checks if it's less than 300. Of course, it is less than 300. So it's going to print that I'm not eligible for a loan. After this, the remaining statements are also simple if conditions. Since they are also simple if conditions, they are independent of this first if condition. This is independent of this is independent of this, and this is independent of this. Since they are completely independent, after checking this condition, it's going to check this condition as well, which makes no sense because we only need to run one of these. Then it's going to check this condition as well, and it's going to check this condition as well. We need to avoid them. So to avoid these, we can make this else if instead. If credit score is less than equal to less than 300, do this. Otherwise, else if it's greater than equal to 301 and less than equal to 600, do this. Again, else if it's greater than equal to 601 and less than equal to 800, do this. And this is the last case scenario. We don't have to provide anything. We just have to write else because else we know it has to be greater than 800 because it does not fit in any of these criteria. So if we write a code in this order, it makes it in such a way that it goes through these conditions dependent to the previous condition. So if my credit score is 280 and this is printed, it should not go to the rest of the code and skip from there. So let's just make this small modification at our end. So if the credit score is less than 300, do this. Otherwise, in other words, we specify it as elif. Elif should always be written after if. It's basically a way to say if this condition is not true, only then execute this.